Hey, so the other problem on the homework that deals with infinite series and I feel like is pretty tricky and you might need some help with is number 5. Let's read it. So number 5 says, I want a cool color and my highlighter. Okay. Number 5 says the following diagram shows CD. This is CD. It's a line with length B centimeters. So the length of CD is B, where B is greater than 1. So just the length of CD is greater than 1. Squares, so these guys are squares, with side lengths K. So if this guy is K and this is a square, then this guy is also K. And then for this guy, his side lengths are K squared. So this guy is also K squared. And then this guy is K to the third, so this guy is also K to the third. Okay, I'm mocking up my figure, looks good. Where K is between 0 and 1, okay. And they are drawn along CD, okay. This process is carried on indefinitely, so they just keep going and going and going and going and going. Whenever they mention indefinitely, that is a sneaky way of telling me that I will be using an infinite sum. The diagram shows the first 3 squares. It says the total sum, I'm going to be using an infinite sum here, of the areas of all the squares is 9 over 16. Find the value of B. So we're trying to find the length of the line segment CD. Okay. The total sum of the areas is 9 over 16. So that's like my clue, right? And I think I should kind of envision what the areas of the squares are going to be looking like in order to see what I mean by adding all the areas together and it becoming 9 over 16 at the end, right? So K times K would give me an area of K squared for the first square. K squared times K squared, remember your exponent rules, right? K squared times K squared, when I multiply like bases, I add the exponents, I get K to the fourth. Oh no, the bell is ringing, I'm sorry. Okay, that would be K to the fourth for the second one, and then K to the third times K to the third would give me K to the sixth for the area of the third square. So I'm gonna use the clue that they gave me, right? You have the first square, right? Let's call him square number 1. Square number 1. His area is K squared. If I put it in a table, I might have an easier way of figuring out what's going on, or have an easier idea of figuring out what's going on. Square number 2, his area is K to the fourth. Square number 3, his area is K to the sixth, so on and so forth. I can probably figure out what's going on here in this case, right? So I have an infinite sum, right? And I have u sub 1 over 1 minus r. Okay, I know that u sub 1 is going to be K squared, right? I have to figure out r. That's what I'm going to try to do with this little table that I just made. I don't know what it is yet, but we'll figure it out. And then the infinite sum, like when I add all these areas of the squares together, is going to be 9 over 16. So I've got a pretty good idea of where I'm headed with this. Let's go. I need to find r. In order to find r, I'm going to do second term over first. So I'm going to do K to the fourth over K squared. Oops. There we go. R is going to be K squared. Okay, so now I'm just going to sub that in where I see the R. Oh, sorry. This is R. Okay, I'm going to sub that in where I see an R. So I have 9 over 16 K squared over 1 minus, you can hear the kids screaming in the hallway. How fun. Okay. I have this little expression right here. This is going to be so nice to solve because all I have to do now is just cross multiply. And I have 9 times 1 minus K squared equals 16K squared. So I'm going to distribute, and I have 9 minus 9K squared is equal to 16K squared. I'm going to sort. And I now have 9 equals 25K squared. I'm going to divide both sides by 25. I'm going to divide both sides by 25. And I have K squared equals 9 over 25. I'm going to square root both sides. K is equal to plus or minus 3 over 5. Okay, so I found K, but that's not what the question was asking me. I needed to find K in order to find B. That is ultimately where I am headed, right? So B is going to be found by the infinite sum of adding all these little segments together, right? So I've got the first line segment's length is K, and that's going to be 3/5. And then since I'm talking about the length of a line, I'm going to ignore the negative version and just take the positive 3/5 version, right? And then I have 1 minus r. I don't know what that r is going to be. Let's figure out what that looks like here, okay? So as I'm finding the length of CD, aka B, right? What I'm going to do here is the first one, or let's just call it 1, right? He's going to have a length of k. The second one's going to have, the second line is going to have a length of k squared. I'm going to keep adding these all together and get like the eventual line's length. So to get from k to k squared, I have to multiply by k. To get from k squared to k cubed, I have to multiply by k. R is equal to k. So I'm going to go ahead and go back over here and just erase this little r here and put in a k. All right, cool. And now I found k. Where is he? K is here. Hooray. So now I can just pop him in where there's a k over here. So I've got b, or the infinite sum, is equal to 3/5 over 1 minus 3/5. And if I put that in my calculator, I get b is equal to 3/2. All right, cool. That's it.